Good day, everyone, and once again, we're back together just looking at vertical projectile motion this time. So, if you haven't subscribed, please just make sure that you're part of this family. And of course, you can always get in touch with us and join our membership feature, right? In this case, there are some value added perks. Just go on to subscribe and join as a member, and you can also benefit from those wonderful perks. All right, let's get right into the question. Right, so we're given there a ball that is thrown vertically upwards from the top of a building of 25 meters, okay, with a velocity rather of 12 meters per second. They say on its way down, the ball passes a door which has a height of 1.9 meters and then strikes the ground as shown in the diagram below. Right? Very important. They say to you, ignore the effects of air friction. Remember, the moment that we rule out the effects of air friction, it means that gravity then becomes the only force that acts on the body as it goes down, right? So in this case, they said to you, define the term free fall. Remember that free fall is motion of an object under the influence of gravitational force only. Please qualify that with only, otherwise then it becomes incorrect as a definition. Okay, right, so the next one, they say to you, calculate the time taken for the ball to reach its maximum height. Now note in this case, ladies and gents, right, so we're looking there from the ball. Now what I'm going to do is, let me just make some label just some points there. Let's call this point A, position B. Let's call that position C when it comes back to the same position where it started from. And let's say D, this is the top of the door. And let's say E is the ground, right? So in this case, we were looking for the time taken for the ball to reach its maximum height. So which position are we looking at? From the beginning, which is position A, right up until maximum height, in this case, which is B, right? So let's take information from A to B. Okay, so that's 3.2.1. Okay, so I'm going to say this is from position A to position B. What is our initial velocity? Now, please note, ladies and gents, it's always good practice for you to choose a direction of motion. So I'm going to take upwards as positive, right? So meaning that anything going down will be negative, right? So in this case, our initial velocity, right, we're given that it moves from 12 meters per second going upwards. So that would be positive 12 meters per second. And the final velocity, meaning we're looking at the velocity at B. Remember that when it gets to maximum height, the ball stops momentarily. So that would be 0. Okay. And obviously, gravitational acceleration always remains 9.8 meters per second squared. But remember, it's always acting vertically downwards. So as a result, therefore, it will be negative 9.8 meters per second squared, right? So the time that it takes, that's exactly what we're looking for. We do not have the displacement either. So whatever equation we pick must be an equation with time, and in this case it mustn't have displacement because we don't have that, right? So now of the 4 equations, remember you've got those 4 equations of motion. The first one, Vf is equals to Vi plus G delta T. Okay, the second one, Vf squared, Vi squared plus 2 times A delta Y or delta X, right? In this case, we're looking at vertical motion. Okay, so delta Y, that's Vi delta T plus 1 over 2A delta T squared. And the last one, delta Y, is Vi plus Vf all over 2 multiplied by delta T, right? So in this case, we're looking for the only equation without displacement. You must note that every single one of these equations is unique, right? So the first equation, or rather the equation without displacement, is the first one, right? So I'm going to say this is Vf, Vi plus g delta t, right? So in this case, our final velocity, we said it's 0, so we are substituting, right? So that would be 12 for initial velocity, that's negative 9.8, and we're looking for time. And taking this to the other side, we've got negative 12 equal to negative 9.8 delta t, and we can divide both sides by negative 9.8. Okay, and what does that give us, right? So it's 12 divided by 9.8, and I get a value of, well, 1.22. So it means that the time that it takes to reach the maximum height would be 1.22 seconds. All right, I hope that is understandable for everyone, right? So in this case, let's go on to the next one. Okay, they say calculate the velocity with which the ball strikes the ground. Now look at this. We're looking now at the velocity at position E. Now, ladies and gents, I want to caution you. Please do not say that the velocity at E is 0, meaning that it will stop when it gets to the ground. We do not actually regard the final velocity as being the moment when it actually strikes the ground, but it's actually just the few sub-seconds just before it strikes the ground. Why? Because gravity is still the only force that's acting at that point, right? So in this case, I'm going to take from position A till position E. I think that will have sufficient information for that, right? So we're looking at 3.2.2, right? 0.2.2. Sorry, I wrote that as 1, but it was 3.2.1. Right, so in this case, we're looking from position A to E, right? Again, what is our initial velocity? That would be 12 meters per second, right? Remember, it's positive because it was going up. Final velocity, that's exactly what we're looking for. We don't know what it is. But gravitational acceleration, remember, because we've chosen up as positive, it means that gravitational acceleration acts vertically downwards, so therefore it becomes negative 9.8 meters per second squared. And the time that it takes, we don't know how long it takes to get to the ground, right? But we do know what the displacement is, right? Now, please, I want us to go back to that diagram there, right? So look at this. When we talk about displacement, we say this is the straight line change in position, right, from the beginning. So where's our beginning? At the top of the building to the end point, which is at E, right? In a straight line, how far is it from position A to position E, right? So you'd see in this case, we started from A till E in a straight line, which is what displacement is about, right? Please, if you don't understand that, please go back to my lesson on vertical projectile motion and you'll understand that even more. So the displacement from A to E will actually be the 25 meters, but note it is displaced downwards, so meaning that it will be a negative, right? Because we said anything that's going up is positive. So it's displaced downwards. So that will be negative 25 meters, right? So in this case, we're looking for the final velocity, right? We do not have the time. So which equation? Of course, it will be the second equation, Vf squared, Vi squared plus 2 times A delta Y, right? So in this case, what is our final velocity? That's what we're looking for. So our initial velocity, we said it's positive 12, but remember it is squared, plus 2 times our A is negative 9.8, and our displacement is negative 25. Okay, now remember, because we're looking for Vf, right? Remember, this is Vf squared. So what we must simply do is take the square root to get Vf, and it will be plus or minus. Now remember, when you take the square root, you actually have plus or minus, but in this case we have to choose one, right? And I'll tell you how we do so. So I'm going to take the square root. Okay, so let's take the square root of 12 squared plus 2 times, that's negative 9.8 times negative 25. Okay, let's make sure that we've got that correctly. Okay, so in this case, we get that value, and I get a value of 25. Remember, we said plus or minus 25.17, well, 18 actually, to be more accurate, right, meters per second. Now, the question is, which answer are we going to take? The positive or the negative in this case? Remember, it is going down, so it means that that final velocity is negative. Now, ladies and gents, remember, negative simply means that it is going down, right? But so because they said to you calculate the velocity with which it strikes the ground, it means you must mention direction. So the velocity will be 25.18 meters per second. And in which direction is that? It must be downwards. I hope that makes sense, right? So that's 25.18. Let me write that nicely. Okay, 0.18 meters per second downwards. Okay, right, now let's go on to the next question. They say calculate the time it took the ball to move from the top of the door to the ground. Okay, so now we're saying, all right, we need to find out how long it took for the ball to move from this position here, which is the top of the ball, right up until it reached the ground right there, right? Now, in this case, ladies and gents, what you may do, right, if you want to, okay, I can try to find out, let's say, just for argument's sake, I can say, look, how long did it take to move from A all the way up until position E, right? But then also find out the time it took from A up until position D, right? And in this case, what will happen? The time till E minus the time till D, the difference there will give us that time there, right? Alternatively, what I can do is to find out what the velocity is at D, right? And simply calculate the time from D all the way up until E, right? That's what I can do. Okay. I guess there are several ways. I'm just discussing a couple of options that we can take, right? So I'm not sure which one, will be to your liking, right? But let me take the first option, and perhaps, if we've got enough time, we can even explore the other one, right? So remember, we said, so that's 3.2.3. So if I take the time from A till E, right, we know what the initial velocity is. That's positive 12. The final velocity, we got it there. That's negative 25.18. We know gravitational acceleration, we said that's negative 9.8, okay? And we want the time from A till E, right? Remember, we also have the displacement, which is negative 25, right? So what we can do is calculate the time that it takes, right, from A till E. So in this case, I'm simply going to say VF is equals to VI plus G delta T. Okay, so that would be negative 25.18. And by the way, if you didn't put that negative, actually it will jeopardize your answer here, right? Positive 12 plus a negative 9.8 delta T, right? And of course, what we simply do, take the 12 to the other side, right? So 25.18 minus 12, negative 25.18 minus 12, that will give us negative 37.18, which is equal to negative 9.8 delta T, right? So negative 9.8, we can divide by it there. And what do we get, right? So I'm going to take my calculator quickly. So 37.18 divided by 9.8. Of course, we know a negative divided by negative will be a positive. So that gives me 3.79 seconds, right? Now remember, that's not the time we're looking for. We're looking for the time from, in this case, D to E, which is the time that it took for it to pass that door, right? So what I can also do is find out what is the time that it took from A till D, right? So again, I'm going to apply the very same thinking, right? Now, in this case, it means that all the information still remains the same, right? Now, I don't know what my velocity is when it got to D, right? The gravitational acceleration, that's negative 9.8, right? And the time, that's exactly what I'm looking for. And in this case, what is the displacement from the beginning to that point D? In a straight line, how far is it from the top of that building, right? So it's at that point there, from the top of the building all the way up until D. You can imagine, ladies and gents, it would be 25 minus the 1.9 here. That would give us the displacement from that point to that point. Now, some of you might say to me, oh, but what about the position when it went upwards, right? Remember that when it went up, regardless of what the displacement was when it went up. So when it went up, in this case, it went, let's just for argument's sake, say it went 8 meters upwards, right? But remember, it would come back again to the same position, so which would be negative 8. So it means the total displacement between A to C would be 0. That's why, in this case, the total displacement between A to D would actually be that straight line position over there, right? I hope that makes sense, ladies and gents, right? So in this case, what we're simply going to do, okay, is just take the difference there. 25 subtract 1.9, that should give us 23.1, right? Okay, some of you don't believe me. So that's 25 minus 1.9, so that's 23.1. But remember, it is displaced downwards, right? So it means that the displacement here should be negative 23.1 meters, right? So now we're going to look for that time, right? And what do we not have? We don't have, in this case, we don't have the final velocity. So what we can do is delta y, that's vi delta t plus 1 over 2 a delta t squared, right? So our displacement, that's negative 23.1. So initial velocity, that's 12 delta t plus 1 over 2 times negative 9.8 delta t squared. All right, you'll see that this gives us a quadratic equation, right? I am not in the mood of solving for that quadratic equation. You can do so perhaps in your own leisure, your own time, right? What I can do, however, even though it might seem as though it's a little bit long, what I can do is, let's say, I can calculate what that final velocity is when it got to, the door, right? When it got to the top of that door. So what I can do is just simply say, right, Vf squared is Vi squared plus 2 times A delta Y. Okay, so in this case, my Vf, that's what we're looking for. Okay, so Vf is equal to, again, plus or minus, okay, the square root of that would be 12 squared plus 2 times negative 9.8 times negative 23.1. Sorry about that, squeezing it in there, right? So let's find that out quickly. Okay, so that's going to be 12 squared minus, or rather plus, 2 times negative 9.8 times negative 23.1. Okay, so I get a velocity value of 24.43, okay, meters per second. Please remember, it's going to be negative because it was going down at that point, right? Now that I've got that velocity, what I can do is calculate the time that it takes. I'm going to use this equation. Vf is Vi plus G delta T, right? In fact, let me just write it at the bottom there. Vf is Vi. Okay, our final velocity, we found it to be negative 24.43. Our initial velocity was 12. That's negative 9.8 delta t. And all I'm going to do is take that to the other side. That will give me negative 36.43, which is equal to negative 9.8 delta t, right? We can find that time out, negative 9.8. And what we have is the following. So that's 36.43 divided by 9.8. And that gives me 3.7 seconds, 3.72 seconds, right? And remember, what were we looking for? The time difference between the two, right? 3.79, okay? Subtract there 3.72. So the time difference will be 3.79 minus 3.72. And in this case, that will give us 0.07 seconds. Yeah, 0.07 seconds. Right, please let me know if you solved it, using this quadratic equation. Okay, what it will give you is the time like we found here, and all that we need to do is obviously subtract that time from the time that it took, going from A to B, A to E rather. So you'll do exactly the same step at the end, and you'll find that answer. Please let me know what answer you get there, all right, so that we can verify if I'm on the right track. Okay, so I hope that does make sense, ladies and gents. Now let's look at the last question. Okay, they say to us, draw a velocity versus time graph for the motion of the ball from the moment that the ball is thrown upwards until it strikes the ground. Use the ground as zero reference, right? Clearly indicate the following on the graph: the velocity with which the ball was thrown, the time taken for the ball to reach maximum height, and the velocity with which the ball strikes the ground. Now, ladies and gents, whenever they ask you to draw these type of graphs, please note that you will already have all the information that you need. Okay, so let's do that quickly. So that would be a velocity versus time graph. Okay, so let's just write that nicely. Okay, so in this case, I know this would be velocity here. Velocity. Okay, and that's in meters per second. Please don't forget to write down the SI units. This is time, and this is in seconds. Right, so all I'm going to do, ladies and gents, what velocity did we start with? We started at positive 12. You remember that, right? So when you go back there, we started at positive 12. And what happened? It started decreasing when it got to B. It was 0, right? So I know when we get to C, we will have negative 12 there. So this would be 0. So it goes from positive 12 to 0 to negative 12, okay? And all the way we got the velocity at this point to be negative, I think 24 point something. Where is that? Yeah, there it is. We got it to be 24.43. That would be the velocity when it reaches the ground, right? So say, so that's negative 12. That becomes 0, right? And how long did it take to get to maximum height? We found that out. That was the very first question, 1.22 seconds, right? So the time was 1.22, okay, 1.22, okay, and we know it will be negative 12 again when the time is 2.44, right? Because remember, it takes the same amount of time going up from A to B as well as from B to till C, right? So I'm just trying to change the color there. Okay, so my graph should look something like that. Okay, so let's try as much as possible, but remember we can even go further down, right? And remember that velocity time graph is a straight line graph. Sorry, you should indicate your axes as much as you possibly can, right? You show them by indicating those arrows there. Okay, so yeah, we must be able to clearly see which ones are the axes. So that would be negative 12 there, okay? And we know that final velocity must be negative 24.43, I believe. Yes, okay, 43. And what was that time when we got to that final velocity? That was 3.79. Yes, that's that time there when we got to the ground. So that would be 3.79 seconds, right? So we've indicated all that they wanted us to indicate there, and even gave them some extras as well. All right, I hope that you understood this question, ladies and gents, and that obviously if you took on another approach, please let me know, and let me know how that goes. All right, otherwise I will leave it here for now. I'll see you guys again next time. Sharp, sharp.